So this is a review for the 7-4 to 7-6 quiz. So if you were doing your review sheet and studying and had a few questions, hopefully this will help you out on some. Again, I'm not going to do every problem, but I will choose at least one in each section to at least get you on the right track. Number 1 is the only one in the section, but find the inverse of the relation. So remember, when we're looking at ordered pairs, which is what a table is, all an inverse does is switch the x and the y coordinates. So x was 1, y was -6, put it in the reverse order. So x is -6, y is 1. And so you are just switching places for all of those x's and y's. So that is it on those ones. Find the equation of the inverse. Remember that the process is that you are going to switch x and y, and then solve for y. Also remember, f of x is y. So if for some reason you've forgotten that those mean the same thing, then write it the other way if that makes it easier for you. So here on number 2, make this a y. So then in my first step, when I switch x and y, it should be x equals -3y plus 5. So subtract the 5 first, -5, -5. These cancel. These are not like terms. So x minus 5 equals -3y, and then I need to divide both sides by -3. Now here is the problem that I see a lot of people not simplifying. Divide by -3, and you have to simplify both of those terms. You can see on the answers on the back that I did that, but that is a requirement to simplify it. Don't just leave it like this, or you're missing the last step. So this is 1x. 1 divided by -3 is -1/3. So that's -1/3 x. -5 divided by -3. It doesn't come out evenly. So all we need to do is say that 2 negatives make a positive. And so my inverse function is y equals, or f of x equals, -1/3 x plus 5/3. So again, just be very careful to simplify as far as you possibly can. All right, I'm going to do one more of these ones, and I'm going to go ahead and look at 5. So again, f of x is the same as y. So my first step is to switch the x and the y. So x equals square root of 4 minus y. If I want to get y alone, I've got to get rid of this square root. The opposite of square rooting is to square both sides. So I'm going to square both sides here. So on the right side, left side, I've got x squared. On the right side, the square root and the squared undo each other. So all I've got is 4 minus y. So now, to get the y alone, I subtract the 4. Again, these are not like terms, so just keep it, x squared minus 4 equals, don't forget that this was a negative y, because then I'm going to need to divide everything by -1. So when y is alone, y equals -x squared plus 4. So switch x and y, solve for y. All right, next section, verify that f and g are inverse functions. The way that we do this is we have to show with work that both f of g of x and g of f of x simplify to x. Again, don't try to fake me out. I'm looking at the work. So please, 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 show every step if you want credit. So I'm going to look at, let's see, the one with the fourth roots I think is perhaps a little harder, so we'll do that one. So f of g of x, that first composition, That means f is the outside function. So I take f with its fourth root of, and then remember where x was, I leave a blank parenthesis, minus 2. Then the inside function is g of x, so I plug g of x, which is x to the fourth, plus 2, in. And now I'm going to simplify. So this is just order of operations, guys. There's nothing I can do with what's inside the parentheses because x to the fourth and 2 are not like terms. So that means I can make my parentheses go ahead and disappear. And now I have to do what's inside the square root. So x to the fourth plus 2 minus 2. Well, these cancel each other. So my next step, I should have the fourth root of x to the fourth. Then the fourth root and the fourth power cancel each other out. And all I get is x. Again, don't try to skip steps. I always get people who try to cross both things off at the same time, which using order of operations, you can't do that. You have to do one before the other. So please make sure you show all the steps if you want full credit. So I'm halfway done here. I've got g of f of x. Now I'm going to, or f of g of x. Now I'm going to do g of f of x. Again, showing all steps. So g is the outside function this time. So I'm taking this. Where the x was, I leave a blank parenthesis, so blank parenthesis to the fourth power plus 2, and then I fill in my inside function f of x into that blank parenthesis. All right, so again, order of operations. First thing, if I have a fourth power and a fourth root, those are going to undo each other. So the root comes away, the exponent comes away, and all I've got is x minus 2, and then on the outside I had plus 2. Now this negative 2 and this positive 2 are going to cancel, and I've got x. So again, you have to show all the work. Again, it's verify. So I know that the answer is yes, because f of g of x and g of f of x both equal x. They should. If you don't get x, they wouldn't be inverses. But again, when I'm grading this, I'm not grading this, I'm grading the steps of work, so make sure that you show it. 8 and 9, super easy. Determine whether the inverse of each graph is a function. This is the horizontal line test. So, all we have to do is draw a horizontal line and see if it touches more than once. This horizontal line touches twice, so this one's a no because it fails the horizontal line test. This one, I can draw all the horizontal lines I want. Each of them is only touching in one spot. So this, yes, the inverse would be a function because it passes the horizontal line test. 10 and 11, describe in words how to get the graph from this. This is the parent graph. So it's just saying what changes are you making to the parent graph with this particular equation. So on this one, I've got this lovely plus 4 and this minus 3. Remember that what's inside the square root or cube root, you change the sign. This is a left shift. Then this is outside the parentheses, so that's the up-down because it's negative. That means it's down. So I shift left 4, down 3. This one, I've got a negative in front, so that's going to mean something. I do have shifts here too. Again, change the sign for the inside. This is right 1. Plus 7 means up 7. But don't forget this negative. That negative means that I am going to reflect in the x-axis. I'm going to flip it. It's going to be upside down from what the typical is. So 12 through 15 are taking exactly what I did here and now asking you to actually graph it. So I'm going to do one square root and one cube root. I'll do my cube root one first. Again, you might want to do what we did in 10 and 11, on these ones just out to the side. This plus 1 means that I'm going to go left 1. The negative 3 means I'm going to go down 3. So if you write this and then do it wrong, I can at least give you partial credit for that work. So my starting point is going to shift left 1 and down 3. So instead of starting at the origin, I start at negative 1, negative 3. So on cube root graphs, there's no number in front here, so that means I'm not making it wider or narrower, so I'm going to go up 1, right 1 to make my top branch, and then I'm going to go down 1, left 1 to make my bottom branch. Domain, my x values, they're going on forever, arrows in both directions, so it's all real numbers. Range, same thing. This is very slowly climbing its y value up. This is very slowly climbing the y value down. So it's going on forever too, just more slowly than the x's are. All right, now I'm going to look at a square root. So let's look at 14. So again, write it out just like we did in 10 and 11. This is going to be a shift of left 1 and up 4, and then I'm going to reflect it in the x-axis. So do the shift first. So I'm going to shift from the origin, because that's where I normally start. I shift left 1 and up 1, 2, 3, 4. So here's my starting point. Now remember, it's reflected, which means it's upside down. So instead of going up 1, right 1, I'm going to go down 1, left 1. Now remember, and it reminds you in the directions, that you have to plot at least 3 points. On the cube root, those are easy. On the square root, you have to come up with another point. I always pick whatever number is going to come out evenly. I know what the square root of 4 is. So if I make x 3, if x is 3, I've got 3 plus 1 under the square root plus 4 and then the negative in front. So if x is 3, then y value, this is 4, square root of 4 is 2, negative 2 plus 4 is positive 2. So when x is 3, y is positive 2, that gives me my third point to connect. Again, it's going this way. Domain, you actually have to look on the square roots. They're not all real numbers. My domain, my x values, look at the x-axis. Where does it start? My x values start right here when x is negative 1. And they get bigger. So all real numbers greater than or equal to negative 1. Range, again, look at it. The y-axis is range. My y values start at 4 and they get smaller. So range, all real numbers less than or equal to 4. All right, last section here, solving the equations, checking for extraneous solutions. So I am going to look, let's see, which ones are probably the hardest ones. 16 and 17, remember that you have to get the term alone first. So get this alone first, then take the 3/4 power on both sides. Get this term alone first, then cube both sides. 18 and 19 are harder, so those are the ones I'm going to go over here. Remember that on the ones where you have two different radicals, you have to get them on opposite sides. So I'm going to move this to the other side by adding it. So add radical x minus 5 to both sides. So I've got square root 3x plus 1 equals square root x minus 5. So now they're on opposite sides. The appropriate power would be to square. So I'm going to square both sides. So I get 3x plus 1 equals x minus 5. So now I just need to solve for x. So subtract x here. Those cancel. So I've got 2x plus 1 equals negative 5. So subtract 1. 2x equals negative 6. Divide by 2. and x is -3. Do not forget to check for extraneous solutions. Notice I'm giving you hints about these things and the directions. When x is -3, if I plug that in, I would end up with square root of -8 minus square root of -8 and having it equal 0. Now, if you take something and subtract the same thing, yes, it would give you 0. But the problem here is that x can't be -3 because when you plug it in, it gives you a negative underneath that radical. So we can't have negatives underneath the radical. So the only solution that we had didn't work. And so in this case, there is no solution. All right, last one, 19. There's only one radical, so we get the radical term by itself and then take the appropriate power. That's nice. The radical term is already by itself. So all I need to do in this case, the appropriate power would be power of 2, is square both sides. So on the left, the square root and the squared undo each other. So I've got 12x plus 13. On the right side, I need to square 2x plus 1. Again, we did these in the notes. We did these in the classwork. You have to FOIL this. It's a binomial squared. So first, 2x times 2x is 4x squared. Insides, and if you need to write it out, but the inside terms, 1 times 2x is 2x. Outside terms, same thing, 2x. And lasts, 1 times 1 is 1. So now I need to solve. This is a quadratic, so we're going to need to get it all to one side. So subtract 12x, subtract 12x, subtract 13, subtract 13. So I've got 4x squared. This is 4x minus 12x, which is -8x. 1 minus 13 is -12 equals 0. So first thing I'm going to do is see if it's factorable. There's a GCF of 4, so I'm going to take that out first. And what do you know? Easy type of factoring, factors that add. What multiplies to -3 and adds to -2? -3, +1. So it was factorable. I end up with x equals 3 and x equals -1. And then I need to check them. So when I plug in x equals 3, I get 12 times 3 is 36, plus 13, 46, 49, so square root of 49 equals 2 times 3 is 6, plus 1 is 7. Is the square root of 49 7? Yes, it is. So we're good on x equals 3. Then I need to plug in x equals -1. 12 times -1 is -12, plus 13 is 1. On the right side, 2 times -1 is -2, plus 1 is -1. Square root of 1 is 1. This is -1, so this is a no. Again, remember, we don't do plus or minuses when we're simplifying expressions. So this guy doesn't work. X equals 3 is our only solution. All right, so hopefully that gets you some help if you were struggling. And if you need more help, remember I am always here early in the mornings. That's it for the recording.